What is the velocity of light in glass with n equals 1.50? We know that n is equal to c over v, and so we can find the velocity by using c over n, and that would be 3 times 10 to the 8th meters per second over 1.50, and the velocity in this glass would be 2 times 10 to the 8th meters per second. How far will light travel in this glass in 10 to the negative 8 seconds? Velocity is distance over time, and we are trying to solve for distance, which is velocity times time. And our velocity we just found is 2 times 10 to the 8th meters per second. And multiply that by the time, 10 to the negative 8 seconds. And that gives us a distance traveled of 2 meters. How far will light travel in air in 10 to the negative 8 seconds? Well, here our d equals v over t would give us the velocity of light in air, 3 times 10 to the 8th meters per second, and the same amount of time we're using, 10 to the negative 8 seconds, and the light in that same amount of time will travel 3 meters. What is the optical path length in each case? Well, the definition of the optical path length is, if given the same amount of time, how far would the light have traveled in air? So the optical path length of the light that traveled through this glass, when it took 10 to the negative 8 seconds to travel through, even though it was 2 meters in the glass, the optical path length was 3 meters because the light could have traveled 3 meters in air in that same distance. But we could use our formula, optical path length equals nd. And so for the light in glass, the index is 1.5, and the distance traveled was 2 meters. So our optical path length in the glass is 3 meters. And the optical path length in the air, the index of refraction of air is 1, and the light traveled 3 meters, so they have an optical path length that is equal, which, since they had an equal amount of time, by definition the optical path lengths would be equal.